Hi everybody, I'm here to talk to you about the different types of reactions. There are 5 of them that we will cover today. We are not going to worry about predicting products yet. We'll get to that later. We're just going to focus on the types of reactions. So the first type of reaction we have is a synthesis, also known as a combination reaction. Okay, so synthesis or combination, that means 2 things are coming together to form one. So we have our general form of A plus B yields A, B, in which I have 2 reactants combining to form one product. So that's the general pattern you should look for. The second type of reaction is decomposition. A decomposition reaction, right, something's going to be breaking down. So I have the general form AB yields A plus B, in which I have one reactant breaking down into 2 products. Right, so those two, the words kind of, definitions of those words themselves really help you identify what's going on in those types of reactions. The third type of reaction we have is a single replacement reaction. In a single replacement reaction, we'll have AB plus C yields CB plus A. And that's if the single element is a cation. Because the cation is always going to be written first. So notice how we put the C in front of the B. But if the single element's an anion, so if we have XY plus Z, for example, you're going to notice that your new compound is going to be XZ plus Y. Again, that's if your single element is an anion. Because the single element is going to replace or kick out the element in the compound that it's most similar to. Okay, so the pattern here is I have a compound plus an element producing a different compound plus a different element. The next type of reaction I have is a double replacement reaction. Okay, a double replacement reaction takes the form of AB plus XY. And again, we're going to do the same thing like we did with single replacement and write the cation first. Okay, what's going to happen is they're going to switch partners. A is going to bond with Y and X is going to bond with B. So we have AY plus XB. Right? Again, I can tell I have a double replacement reaction because I have 2 compounds that switch partners to produce 2 compounds. All right, so the difference between these, single replacement has a single element, double replacement's got 2 compounds. Then the last type of reaction is combustion. Okay, with a combustion reaction, we have a hydrocarbon. A hydrocarbon is a carbon-hydrogen compound. I put X and Y because there are different ratios at which carbon and hydrogen can bond. So I'm just leaving that open-ended. And then really what defines a combustion reaction is the reactant of oxygen. And the hydrocarbon plus oxygen is always going to give you carbon dioxide and water. So that's how you can identify the combustion, is with the hydrocarbon plus oxygen giving you carbon dioxide and water. Okay, it starts off very much looking like a single replacement reaction, but you just have to pay attention to what's reacting and pay attention to the hydrocarbon, oxygen, carbon dioxide, water situation. Balancing is hard for these, or they can just be a little tricky because you have the oxygen in the two compounds on the product side. So I like to give tips on balancing. First, you're going to balance the hydrogen, then the carbon, and then the oxygen. One thing to pay attention to is the fact that if you have an odd number coefficient in front of water, that's going to give you an odd number of oxygens on the product side. Given that you have a subscript of 2 over here, you can't have an odd number. Okay, so if when you're balancing the hydrogens, if the coefficient is odd, double it and put a 2 coefficient in front of the hydrocarbon. And then you should be able to balance everything else just fine from there. So why don't we go ahead and do a couple examples together. Okay, so here, okay, so I'm just going to be looking for patterns. Here I have, so we're going to look at the patterns of the reactants and the products. Okay, so here I have one reactant breaking down into 2 products. So if we look back at our sheet, okay, one reactant breaking into 2 products is decomposition. So this reaction would be decomposition. Now, if you want a little review on balancing, okay, I can create my atom inventory. See, I have 1 mercury and 1 oxygen, 1 mercury and 2 oxygens. So, since the reactant side is less oxygens, I want to put a 2 coefficient here. That is 2 times 1 oxygen, which gives me 2. That also changes up how many mercuries you have. You also have 2 mercuries. So now that leaves the mercuries unbalanced, so you need a 2 coefficient in order to balance them, because you always multiply the coefficient by the subscript, and if there's no subscript, that subscript is just 1, so it's just 2 times 1. And you can leave the spot in front of oxygen blank, or you can put a 1 in there, whatever makes you more comfortable. With number 2, I have 2 compounds that switch partners to give 2 compounds. So that points to double replacement. Having a little bit of a hard time scrolling down to that on here, but you can see, you'll be able to see that. So this is actually going to be double replacement. To balance, I have sodium, chlorine, silver, and I do have NO3 on both sides, so I can keep that together. I have 1 sodium on each side, 1 chlorine on each side, 1 silver, 1 nitrate. I know it looks like 3, but I just have 1 nitrate on each side, so that's actually already balanced. With number 3, I have 2 reactants combining to form 1 product. So this is a synthesis or a combination. You want to write out combination and not just put a C, because I could confuse that with combustion. So you want to just, if you're using the word combination, write it out. Balancing, I have chlorine and calcium. 2 chlorines, 2 chlorines, 1 calcium, 1 calcium. That's already balanced. With number 4, okay, it looks like a single replacement, right? Because I have a compound and an element. But notice this is a hydrocarbon because it's a carbon-hydrogen, and I have CO2 and water. So this is actually combustion. Now remember, you want to balance your hydrogens first, carbons, and then your oxygens. So I have 2, 6, and 2. 1, 3 oxygens, because 2 from carbon dioxide and 1 from water, 2 here. All right, so that would, in order to get 6, I would need to put a 3, but that's an odd number. So what I told you before is you need to double that. So make that a 6 and that a 2. So now I have 12 hydrogens on both sides, because 2 times 6 and 6 times 2. I have 4 carbons. So to get 4 carbons, I would need to put a 4 coefficient there. And now I'll do the oxygens. That's 4 times 2, which is 8, plus 6 times 1, which is 14. So I would need a coefficient of 7. And then the last one, I have a compound and an element, giving me a compound and an element. So that must be single replacement. Balancing 2, 1, 1, 2, 3, 2. So to get 3 oxygens, I need to put a 3 there, and that gives me 6 hydrogens. And I would put a 2 here, which gives me, oops, not a 2 there, my apologies. I need to put a 2 in front of this iron to give me 2 irons, and then a 3 here to give me the 6 hydrogens. Now that's balanced. All right, I hope this was a good review for all of you.